By the late 2020s, the race to Mars is going to look entirely different. Global powers are currently developing high-end technologies, including nuclear space engines, to slash the travel time across the solar system. We are also seeing a massive leap in robotic capability. By 2028, American and European missions will attempt to drill deep into the Martian crust, hunting for preserved organic signatures that have been shielded from radiation for billions of years. But looking only at the massive budgets of the West ignores the most disruptive player on the board. India has built its space program by repeatedly finding ways to bypass the traditional, high-cost rules of planetary exploration. To understand why the world is watching ISRO's next move, we have to look back at the shockwave they sent through the industry in 2013. On November 5, 2013, the Mars Orbiter mission, or Mangalyaan, began its journey using an indigenous propulsion system. It was India's first attempt to reach another planet. The results were historic. India became the first Asian nation to reach Martian orbit, and the only space agency globally to succeed on its first attempt. What was designed as a brief technology test ended up operating until late 2022. ISRO managed to maintain the mission for 9 years at a fraction of the price of any comparable Western project. However, Mangalyaan was strictly just an orbiter. Transitioning from a stable orbit to actually touching the surface is a move into a much more dangerous frontier of physics. To maintain its standing in this elite tier of exploration, ISRO cannot rely on past orbital successes. They must now solve the problem of landing. India's response to the new space race is the Mars Lander mission, unofficially called Mangalyaan-2, which is currently targeting a launch in 2030. This mission represents a significant shift, moving from a single orbiter to a multi-vehicle surface operation. The strategy involves two primary physical components: a stationary lander to reach the ground safely, and a mobile rover to physically traverse the Martian terrain. Perhaps the most radical addition is a Martian rotorcraft. This helicopter is being designed to scout from the air, providing a perspective that rovers on the ground simply cannot achieve. By deploying a lander, rover, and helicopter simultaneously, India is moving toward a comprehensive, multi-domain exploration of the Red Planet. The engineering hurdle here is unique. The Martian atmosphere is thick enough to burn up a spacecraft on entry, but it is too thin to provide the drag needed to slow down for a soft touchdown. ISRO's supersonic parachutes deploy at incredible speeds to shed momentum in the thin atmosphere. Parachutes only do part of the work. Nearing the ground, retro rockets fire to halt the descent, while a sky crane lowers the rover to the surface. Development on these descent mechanisms and the long-duration cruise stage is already underway in ISRO's facilities. Mastering this sequence of autonomous maneuvers is widely considered the most difficult physics challenge in the solar system. To date, only the United States, China, and the former Soviet Union have successfully landed and operated hardware on the Martian surface. If the 2030 mission succeeds, India will become the fourth member of that extremely small geopolitical group. The contrast here is the budget. While NASA and ESA rely on heavy infrastructure and massive financial outlays for their 2028 missions, India is attempting to reach the same technical milestones using a lean, cost-efficient model. They are proving that indigenous engineering and strict resource management can deliver the same high-stakes results as a superpower-sized budget. The arc of this program is clear. Mangalyaan-1 proved that India could reach the Red Planet on a budget. Mangalyaan-2 is the next step, intended to prove that ISRO can manage the complexity of landing and operating multiple vehicles on another world. These capabilities, entry, descent, and landing, are the mandatory foundation for any future presence on Mars, including potential human scientific bases beyond the 2030s. By successfully landing this coordinated fleet, India transitions from a participant in the space race to one of the few powers capable of defining how we explore the surface of other worlds.